Welcome students. Let us carry forward our discussion on the topic friction. The next problem on friction says that two blocks W1 and W2 are connected by a horizontal bar AB supported on rough planes as shown in the figure. Considering the coefficient of friction between the block A and ground as 0.4 and angle of friction of block B is 20 degrees, find the smallest weight W1 for which the equilibrium can exist if W2 is 2250. So before proceeding further, what we do is we first decide the direction of motions for both the blocks. As block B has some self weight and it is kept on inclined surface, it will try to move in this particular direction. That means down the plane. So this is the direction of motion for B. And as B moves down, this block A will try to move on the left hand side. So these are the directions of motions. Now let us start with the free body diagram of block A and block B. So starting with block A, so first of all, I will isolate the body from all the contact surfaces. Then first thing we show is the applied force, which is not there directly, but there is a rod which is connected. So in rod, we will show a tension force which is directed away from the body. So this is tension T. Then self weight. In the question, it is given that a block W1. So this will be the self weight acting vertically downwards. W1. Then reaction from contact surface. As you can see in the diagram, the surface is horizontal, so reaction will be vertical because it should be perpendicular. So connecting it in the free body diagram, this will be your reaction from contact surface N1. And then we have friction force. So as the block A is moving towards left side, this will be shown towards right hand side. Friction force will be shown towards right hand side with a value of 0.4 multiplied by N1. So this completes three body diagram of block A. So writing the equations, summation of Fx is equal to 0. I will get T plus 0.4 N1 is equal to 0. Let this be equation number 1. Similarly, when I write summation of Fy is equal to 0, I can write N1 minus W1 is equal to 0, or I can write N1 is equal to W1. Let this be equation number 2. Now, going for the free body diagram of block B. So first of all, I will isolate the block from all the contact surfaces it has. So this is how the isolation is done. Then applied force directly is not there, but indirectly there is a rod which is attached, and we have shown it as a tension in the cable or in the rod T. Then self weight will be acting vertically downwards, W2. Then it is reaction from contact surface. This is the part where students make the mistake. Here in the diagram, in the main diagram, you can see that the surface on which it is kept is an inclined surface in this particular direction. So if this is a surface, the surface reaction should be perpendicular. So the direction should be like this. If I draw it here, it's a surface. So this will be the reaction, perpendicular. This will be the reaction to be shown. Now, regarding the angle, what we can see in the diagram again, if this angle is given as 30, this angle will become 60 because total angle should be 90. And if this is 60, I will put it up here, 60 degrees. In this triangle now, this is 60, this is 90. So this will become 30 degrees. So we got that the reaction, the angle made by the reaction with horizontal is 30 degrees. So I will just mark it in the free body diagram that this is the reaction. Let us say name it as N2, and I will tell it that it is making an angle of 30 degrees with the horizontal. Then the last force is the friction force. So as this is moving inclined plane on an inclined plane down the plane, friction force will be up the plane. So the friction force will be shown up the plane with a value of mu multiplied by n2. Here mu is also not given directly, but we are given that in the question angle of friction is 20 degrees. And we know that mu is equal to tan alpha. So I can get mu value from here. Mu is equal to tan of 20, which is equal to 0.364. So here I will write it is 0.364 N2. So this completes our free body diagram. Now, before proceeding further, we have to resolve the inclined forces. So this will be resolved in this particular case. This will be N2 sine 30 and this will be N2 cos 30. Similarly, the other inclined force, this will be resolved like this in x and y. So this will be 0.364 N2. Now regarding the angle, we know that the friction, if you observe the diagram on the right hand side, this is the plane on which it is sliding. And we are given that this plane is making an angle of 60 degrees. We just now found out that this angle is 60. Hence, this angle will also be 60 degrees. So this component will be 0.364 N2 cos 60 and this will be N2 sin 60. So this completes the entire free body diagram. Now I will write the conditions of equilibrium. First condition, that is summation of fx should be 0. So I will get minus t minus n2 cos 30 plus 0.364 n2 cos 60 is equal to 0. Let this be equation number 3. Similarly, if I write summation of fy is equal to 0, I will get one equation as n2 sin 30 plus 0.364 n2 sin 60 minus W2 is equal to 0. The weight W2 is already given to us in the question as 2250 Newton. So substituting W2 as 2250, the only unknown now remains in this equation is N2. So substituting the value of W2, I will get the value of N2 from this equation as 2759.94 newtons. This is the value of N2 which we got from here. Now, as we got value of N2, we can put this value of N2 in this particular equation at this particular place and this particular place. So now the only unknown in this particular equation will be T. So putting the value of N2 as 2759.94 in the equation number 3, I will get the value of T as minus 1887.86 newtons. Now, as we got the value of T, we can now substitute the value of T in this particular equation, equation number 1, and I can get the answer for N1. So I will get N1 is equal to 4719.67 Newton. And once I get N1, I can put this value of N1 in this particular equation, equation number 2, wherein I will get the value of W1 as 4719.67 newtons. Question asked. The requirement in the question was to find out the weight W1. So weight W1, the value will be 4719.67 Newton to maintain the equilibrium. One point worth noting in this particular problem is we got the answer for T as minus 1887.86 Newton. What does this minus indicate? This minus indicates that there will be a compressive force in the rod. So that is, I can write here, that is T is equal to, I will write it positive, 1887.86 Newton, and in bracket I will write C. That means it comes as compression. So this completes the solution of the question which was asked for 8 marks in December 22 exams. Again, what is the observation? Observation is exactly same. We have drawn the free body diagram, we have wrote the conditions of equilibrium and got the required answers. Okay, let us now proceed further to the next problem. Two bodies A and B weighing 90 Newton and 60 Newton respectively are placed on an inclined plane by a connecting string which is parallel to the plane as shown in the figure. Find the inclination of the minimum force P. This is the most important part. Minimum force P for the motion to impend in the direction of P. Take mu is equal to 0.2 for all surface of convex. Again, before proceeding further, as we have the method of finding out the direction of motion, it is given that we have to find the motion to impend in the direction of force. So in the direction of force, this 60 Newton block will be moving towards the right hand side. And because this is moving towards right hand side, this 90 Newton block will be moving up the plane. So these are the directions of motion for block A and block B. Now, starting with the free body diagram. So first I will make a free body diagram of this body of 90 Newton. So first thing we'll show is the applied force. There is no direct applied force, but there is a cable in which we show the tension away from the body. So this will be the tension in the cable. Then self weight, which is given as 90 Newton. Reaction at contact surface. This surface is inclined in this particular angle. So the reaction will be perpendicular in this particular direction, which I will show here in the free body diagram like this as N1. And then friction force, as body is moving up the plane, friction force will be down the plane with a value of 0.2 N1. Now, the only inclined force in this particular diagram is the weight, which I will resolve it into X and Y components. So as the force is vertical, it will make angle with respect to vertical component. So this is 55 degrees. So here it is 90 cos 55 and this is 90 sin 55. Now, applying condition of equilibrium, summation of fx should be 0. I will get minus 0.2 n1 minus 90 sin 55 plus t is equal to 0. So if I just rearrange the terms, I will get t minus 0.2 n1 is equal to 90 sin 55. Let this be equation number 1. Similarly, when I apply summation of fy is equal to 0, I will get n1 minus 90 cos 55 is equal to 0. So from here I can get the value of n1 directly as n1 is equal to 51.62 meters. And once I got n1, I will put this value of n1 in this particular equation 1 to get the answer for t. So I will get answer for t as 84.04 meters. So this completes the entire free body diagram and the calculation for block of 90 Newton. Now, let us go for the second free body diagram. So I will isolate the body from all the surfaces. Then the first force is the applied force, which is already given to us as P. Then we have tension in the cable away from the body T. Then self weight will be shown vertically downwards as 60. reaction from contact surface. As surface is horizontal, reaction will be vertical, perpendicular. So here I will show it as a perpendicular, let us say N2. And as the block is moving towards right side, friction will go towards left side with a value of 0.2 N2. Now, before proceeding, we have to resolve all the inclined forces. So here the inclined force is only P, whose angle is not given to us. It is given as theta. So I will write it as P cos theta, and this component here will be P sin theta. Now, just applying the conditions of equilibrium, summation of fx equal to 0. So I will get P cos theta minus 0.2 N2 minus T equal to 0. Here I already know the value of T, so I will substitute the value of T here, and I will get P cos theta minus 0.2 N2 minus 84.04 is equal to 0. Let this be equation number 2. And when I apply summation of Fy is equal to 0, I will get N2 minus 60 plus P sin theta is equal to 0. Or I can write N2 plus P sin theta is equal to 60. Let this be equation number 3. I will just write these two equations again, which we have got as equation number 2 and 3. So I will write P cos theta minus 0.2 N2 minus 84.04 is equal to 0. This was our equation number 2. And equation 3 we got as N2 plus P sin theta is equal to 60. This was equation number 3. Now, what I can do is, it's now just the mathematical part which we have to do now. So what I can do is, from this particular equation number 2, I can find the value of N2. So if I just rearrange it, I will get the value of N2 as N2 is equal to, I'm just rearranging the terms and finding out value of N2. N2 is equal to P cos theta minus 84.04 divided by 0.2. Okay. Let this be equation number 4. Now what I will do is, I will put this value of N2 here in this particular equation, so that I have only equation in terms of P and theta. So if I put this value of N2 here, I will get equation as P cos theta minus 84.04 divided by 0.2 plus P sin theta is equal to 60. Now, just multiplying by 0.2 on all the sides, I will get P cos theta minus 84.04 plus 0.2 into P sin theta is equal to 60 into 0.2 comes out to be 12. Rearranging the terms again, I will get P cos theta plus 0.2 P sin theta is equal to 12 plus 84.04, which will come to be as 96.04. And again, if I take common P common from here, I will get P cos theta plus 0.2 sin theta is equal to 96.04. Or I can write value of P as P is equal to 96.04 divided by cos theta plus 0.2 sin theta. Let this be equation number 5. Now the important part. In the question, it was given to us that find the inclination of the minimum force P. Inclination to be minimum for minimum force P. So we have the concept to find out minimum of any equation. We have derivative should be 0. So what I will write, therefore, for minima, derivative, that is dt by d theta, should be 0. So we have to take the derivative of equation 5 with respect to theta. So what I will get is 96.04 will be as it is. Derivative of 1 upon x will be minus 1 upon x square. So it will be minus here, and x square, that means cos theta plus 0.2 sine theta square, multiplied by, because it is not x, we have to apply chain rule also. So multiplied by derivative of cos theta, which is minus sine theta, plus zero point 0.2 derivative of sine theta will be cos theta. This should be equal to 0. Now, just see this entire term is in multiplication. If I send it here at this particular place, so everything will become 0. And I will remain with the equation minus sine theta plus 0.2 cos theta is equal to 0. Or I can write 0.2 cos theta is equal to sine theta. Or I can write, or 0.2 is equal to sine theta upon cos theta. And we know that sine theta upon cos theta is tan theta. Therefore, I will write 0.2 is equal to tan theta. That is, theta is equal to tan inverse of 0.2, which will come out to be as 11.31 degrees. So this was the output which was asked. Find the inclination of the minimum force P for the motion. So the minimum inclination force is theta, which is equal to 11.31 degrees. This completes the solution. So again, what I want to highlight here is we have done exactly the same thing what we have done in the previous problem, that is drawing the free body diagram and writing the equations. After writing the equations, we just have to play with the equations by rearranging it here and there and using some mathematical properties to get the desired answers. Yes, so hope you have understood the concepts. So with this, we have completed the topic on friction, wherein the bodies were connected to each other either by means of a rope or by means of a rod. In the next class onwards, we will find out, we will deal with the cases when the blocks are kept one over another. So if there is one block over another block, how the problem will be solved in that particular case. So till then, hope you have enjoyed the sessions. Thank you.